Hi, everybody. We're going to start on the final section of solving equations from Algebra 1 IXL. This is J11. We're going to solve linear equations. It's a mixed review, so there'll be different kinds of problems in there. Hopefully they'll mix it up from the whole section, and it looks like fun. So let's get started. Let's see what they got for us. All right. There's two ways to solve this one. A lot of people would distribute the 4 to both parts and then go through 2 more steps. But there's a more direct way to do this. We're going to undo both sides by doing the opposite in reverse order. And look at J. You see how they're adding the 12 to J? Take a look. You see, if I think of this in terms of what's happening to the variable, I'm first adding 12 to J. That's inside the parentheses. Then I'm multiplying that number by 4, and I get negative 20. Now, in order to undo this, I have to do the opposite in reverse order to both sides. Let me show you another way of looking at this. If you take J and add 12, see it right there? And then I multiply it by 4, I get negative 20. In order to get back to J, I have to do the opposite in reverse order. So the first thing I have to deal with is doing the opposite of multiplying by 4. So what I'm going to do is divide by 4 to undo that. And it looks something like this. Divide by 4 on both sides. The 4's simplify and give me 1. I don't say they cancel out. That's probably a bad way to say that. Multiplying by 1 is the identity for multiplication. So I just get J plus 12 is equal to negative 5. And then to get rid of that plus 12, I have to do the opposite. I have to subtract 12. So I subtract 12 from both sides. You can think of it as adding a negative 12. It means the same. And J, of course, is equal to negative 17. And if you think of it this way, I'm at negative 17. And if I add 12 and multiply by 4, I'll get to negative 20. Anyway, there's my solution. We could have started by distributing the 4 to both parts, and then we would have added and subtracted different things. But this is more direct. So here it is. Get rid of that for a second. Let's put it in. And we're looking at negative 17. Probably over-explained, but I tend to do that on the first problem. All right, this one, there's a very common mistake that happens, and I want to show you the mistake. So what I'm going to do is I'm going to write the mistake over here, so you can see not to do this. A lot of times what happens is students see C over 3 is equal to 3. And a lot of times you are dividing by a number on both sides. And so they'll put the 3 over here and get C equal to 1. What I have to do is the opposite. C is being divided by 3. So I have to multiply by 3. And sometimes it's a little confusing as to where you're supposed to write that 3. This 3 simplifies with this 3 to give you 1C is equal to 9. If the mistake would be to do this, which of course is wrong because you'd still have C over 3 equal to 1, which isn't even true. So bad idea. This, of course, is 9. I like this one. Negative 12 over D is equal to 4. So there's a couple of ways of thinking about this. Some people like to think of this as a proportion, and they'll write negative 12 over D is equal to 4 over 1, and then cross multiply and solve that way. It's the same thing that I'm going to do, except I'm just going to do it more formally. I multiply by D on both sides. And the D's cancel out, assuming it's not 0. And you get negative 12 equals 4D. And then we're going to divide by 4 on both sides. You can see cross multiplying is going to give you the exact same result, which is negative 12 over here and 4D on this side. And in order to solve it, we just divide by 4 and positive 4, sorry. And we get negative 3. I was getting ahead of myself. There we go. And d is equal to negative 3. Okay, we have a little bit of combining like terms over here. We've got negative 11 plus negative 2m, or just minus 2m, it's not wrong to write that, is equal to negative 8m plus 19. Now, the problem that a lot of students run into is that they're not sure what to do first. And a lot of times they'll add the 11 and then they get confused as to which side the m's are going to end up on. Probably the safest bet is to add 8m to both sides. By the way, this is a mistake. I just want to point out a mistake. This is wrong. First of all, I know you mean 8m and you know you mean 8m, but if you don't write what you're really adding here, it will lead to errors later. I promise it will happen. That is 0, and we have 19 over here by itself. This is just 0 right here. And over here, we've got 6m plus negative 11. And I'm going to have to add 11 to both sides. And I'm just going to do it in my head. Adding 11 to 19 gives you 30, and dividing by 6 gives you 5. I'm dividing by 6 on both sides. I'm adding 11 to both sides. Very common mistake on this one, and I want to point out this weird error. I showed it in the last section as a mistake. I think I did a J2, the last one I uploaded, but it says this: 5 minus y equals 1. And there are two main approaches to this. I'm going to show you the straightforward method for solving this. What am I doing? Can't even copy the question right. There we go. 1. All right. I could add negative 5 or subtract 5 from both sides. Perfectly acceptable, nothing wrong with that. The problem is that a lot of people lose their negative and they're not sure what to do about it. And they get their negative 4 over here, and then they have to divide by negative 1 or multiply by negative 1. Interestingly, it doesn't matter which one you do. Either way, if I multiply by negative 1 on this side, I'm going to get positive y. If I divide by negative 1, I'm going to get positive y. It's probably more obvious to most people that they need to divide by negative 1. So that's what I'm going to do, and I'm going to get 1y by itself is equal to 4. Perfectly acceptable. Now, one of the worst mistakes you can possibly make, if you really think about it, is to do everything wrong and still get the right answer. So I'm going to show you a very common mistake, and you can't believe how common this is. Students look at this and they see a y and they see a subtraction and they see a 5 and they just don't know what to do about this situation. So what they do is they say, oh, I'm just going to subtract 1 from both sides. Now, in and of itself, that's not wrong. But here's what what they should get here is 4 minus y. This is what they should get. 4 minus y equals 0. But surprisingly enough, that isn't what happens. This is what happens. Students will subtract 1 on both sides. And of course, this is wrong, but here's what they'll do. 5 minus 1 is 4. And 1 minus 1 cancels out. So there's nothing there. And they're missing an equal sign now. So they just stick the equal sign in the middle here. That sort of looks like an equal sign. And then they get the right answer. And they think, okay, first of all, what happens is they start thinking that algebra makes no sense. So please avoid that error. You'd be surprised at how often it happens. Let's put it in there. This one we're going to subtract 8b from both sides and get 4b plus 17 is equal to negative 15. Don't lose your negative. We need to add negative 17 to both sides, and we get 4b is equal to, that's interesting, It's going to be a fraction. Oh, no, it's not. Negative 32. And then we're going to divide by 4 and get b equal to negative 8. If you need to see the steps, go back and take a look at some of the earlier ones I've done. This is negative 8. All right. This is another one of those weird errors. What people will do is add 9h to both sides and turn the subtraction into an equation. Really bad idea. So negative 9h is equal to 13 minus 8h. And I'm going to have to add 8h to both sides. Again, it's not wrong to add the 9h. It's just going to leave you with problems, okay? That is negative 1h, if you like, is equal to 13. And we're going to have to divide by negative 1 or multiply by negative 1. In IXL, they generally say, I'm going to multiply by negative 1 on both sides, which I'll just show it to you. It does work. This is positive h, and this is negative 13. More common is to divide by negative 1 on both sides, but it doesn't matter. This is negative 13. In this one, we're going to multiply by m on both sides. Again, you could have set up the proportion and cross-multiplied. I want to point something out. Cross-multiplying is the same as multiplying both sides by the denominator. And the m's cancel out, give you 1. So I have 12 is equal to negative 3m. And we have to divide by negative 3 and get our negative 4. Let's see here. Lots of ways to go. Obviously, if you take 2 minus 1, you're going to get 1. So I am going to violate my rule that says don't solve it in your head by filling in the blank. This is one of those cases where it's so obvious, you might as well just fill it in, okay? This one, I'm going to subtract 12w from both sides and get 8w plus 12. I could subtract the 12 on the same step, but I'm just going to go ahead and write it. And now I'm going to add negative 12 to both sides so that I get 8w is equal to negative 32. And then I'm going to divide by 8 and get negative 4. Looks like they like that negative 4 answer for some reason. All right. Common error is to not put these together. They do go together. That is negative 19 plus 17y is equal to 17 minus y. I have to add y to both sides. And if you recognize it, here's a little shortcut for you. If I add y to both sides, be careful. 17 y's and one more y makes 18 y's. If you think of variables as things, like 17 yaks, and if I add a yak, I have 18 yaks. So hopefully that helps. I realize that hopefully I'm going to add 19 to both sides. So I'm just going to go ahead and do it all at one time and make it easy on myself. By simplifying this, that's going to give me 18 yaks is equal to 19 and 17 makes 36. And I'm going to divide by 18 and get my 2. Now, don't panic if this had been any other number than, say, 6 or 12, where it's divisible. If this had been 17 or 15 or 19 or some other number that doesn't divide evenly, don't worry. Just divide on both sides and you get an improper fraction. Who cares? Just write it down. You could change it to a decimal, divide it, whatever you want to do. But these work out really nice. So easy cheesy. Okay, we're going to subtract 3 and divide by 5, and I'm going to get 1. Do it yourself if you can't see it. Divide by 2 and subtract 1, and you get 4. I'm dividing by 2 on both sides, and then I'm subtracting 1 on both sides. If you want to distribute the 2, subtract the 2, and divide by 2, you can do that. It's just easier Divide by 2 on both sides, and what you get is k plus 1 is equal to 5. And clearly, you subtract 1 and get k equal to 4. Be careful. That one's going to give you negative 4w equals negative 20, so w is 5. Come on. This one is going to be 4c equals 8. These just cancel out, don't they? That's 0. So we have c equal to 2. Divide by 4 on both sides. This one we're going to have to add 4n to both sides, and we're done, because you get n equals 16. Take a look. Add 4n to both sides. I promise it'll work. In this one, we're going to add 6 and then divide by 3, which is going to give us 3. 3m is equal to 9, because I added 6 to both sides, and then I divide by 3, and I get 3. And we're almost done. We're getting there. Divide by 7, and you get negative 2. Looks like a lot of steps here. I'm going to point out an error that you really got to watch for in these type. Plus 19r is equal to negative 5 plus 5r. Okay, a lot of people see the 5r over here and they realize that they need to subtract 5r from both sides. But what happens, and this gets funky, they see this negative 13r and this 19r, and they want to do this. This is wrong. This is wrong, wrong, wrong. There are all sorts of things wrong with this. Mainly, I'm adding 26r to one side and nothing to the other side. This is absolutely wrong. This 19r gets added to negative 3r, and the minus 18 is still there. That gives me 6r. We can subtract 5r from both sides, and we get r minus 18 equals negative 5. We add 18 to both sides, and we get our 13. So our solution, of course, is 13. Okay, looks like we're almost done. This one, there's 40 S's. There's 80 S's. That makes 120 S's. And I have negative 51, and I have negative 37, which makes negative 88 S's. I'm going to do something on the side. That happens to be 32. Now, you might have noticed I did it very fast without doing any carrying or borrowing or anything. The reason I know it's 32 is because 88 is 12 less than 100. And I took away 100 and added 12. It's just an easy way of dealing with subtractions. Anyway, I get 32s. This double negative 1 gives me plus 1, and it's equal to 33. I subtract 32. Sorry. Hang on. I subtract 1 rather, and I get 32. And then I divide by 32. I get s equal to 1. Oh, lots of stuff going on here. Let me show you a trick. I like this one. Now, what most people are going to do is they're going to distribute this negative 7. They're going to distribute this negative 7, and then they're going to start adding and working with all these ugly numbers. They're going to get big, ugly numbers, all sorts of things. I'm going to show you a trick here. This is one term. A term is the result of a multiplication. And the reason that this is one term is because all of this stuff is in parentheses. There are two terms inside the parentheses, but this whole thing is really one term, okay? Just something to keep in mind. Now, this one is also one term because again, it's one big multiplication. So this is one term. And this 14u is being added to this term, so it's one term. Now, what I'm going to do is I'm going to divide all my terms by -7. Watch what happens. Trust me, you'll see. You're going to like this. Divide by -7. I'm going to divide by -7. It is really easy to make an error here, but it's a lot easier to make errors when you start multiplying big numbers times -7 and adding them and joining them together and all that. Anyway, dividing by -7 gives me 1. The 1 distributes and eliminates the parentheses, if you like to think of it that way. And over here we've got -7 cancels with -7 to give me 17u minus 68. And notice I have a -2u over here. This is a much easier problem than the other one. Notice I've simplified everything a lot by doing this. I could subtract the 2u from the 17u and get 15u. And I'm going to end up subtracting 14u from both sides and getting 65 is equal to 1u minus 68. And I'm going to have to add 68 to both sides and get 133, it looks like. So add 68, add 68, and you get u equals 133. This could have been a real pain if you had distributed those -7s. Anyway, there it is. Oh, can't do it on this one. Well, you could, but I think you're better off just going ahead and distributing the 4, because dividing this by 4 would be a nightmare, and dividing this by 4 would also give you a nightmare problem. So I'm going to go ahead and distribute my 4. 4 times 27 is 108. So I've got 108d minus 87 times 4 is 148, I believe. And minus the 68. All I did was distribute the 4. If you can't multiply in your head, it's okay. It's good practice though. That's equal to -31 plus 97d. I'm going to do a couple of things all at once. I know that I need to subtract 97d on both sides to get it together. And that's going to give me 11d. When I subtract 97d from this side, and I subtract 97d from this side, that gives me 11d down there. Got it? Now I have a -348 and I have a -68, and that's going to be -416. And that's going to be equal to -31. And now I'm going to add 416 to both sides. Man, this can give people all sorts of problems. This is a tough addition to do. I think it's 385, but it's a lot of people are going to have trouble with this addition. So a good idea is to do the work on the side. That's going to be 416, and I'm going to take away the 31. Most people really need to write it in this direction to make it a little bit nicer. And then it becomes obvious. That's going to be a 5, and 3 from 11 gives you the 8. And we borrowed 1. Sorry, 3. And we borrowed 1, and that gets our 385. And we have 11d is equal to 385. And when you divide by 11, you get 35. So d equals 35. Now, you didn't have to do all this in your head. I mean, you could have grabbed a calculator. But the whole point to this that I want to really point out is that by using your brain, it actually grows when you're doing the math. When you grab the calculator, your brain turns off. So 35. Let's put it in there. Come on. What? Get in there. There we go. Hopefully I didn't make any errors. Let's see here. Looks like I could divide by 8, but nope, the 68 isn't divisible by 8. So we've got -72 minus 68w And I'm going to have to distribute my 8 times the negative 14, and then the 8 times the 57. 8 times the negative 14 is negative 112, it looks like, W. Yep, plus, and then I'm going to multiply the 8 times the 57, which is going to be 456. And I'm going to go ahead and add the 68. No, I'm going to add the 112W to both sides. Don't put plus 112, put plus 112W. And I could add the 72 at the same time. I think I will. I'm going to add the 72 because I kind of know where I'm going with this. Because these are going to cancel out and these are going to cancel out. I'm going to have W's on one side and numbers on the other. You don't have to do them all in one step. It's just, I like it better that way. It looks like we're going to get 32 and 12 makes 44W. If you don't know where I got the 32 from, think about it a little bit. It might make sense to you. That's 44W. And over here, it looks like we get 528. And it definitely looks like 44 might just go in there evenly. And it does. W goes in there, 44 goes in there evenly 12 times. And if you need to, you could show the division on the side here. Let's put the 44 into 528. And of course, the worst option of all is to grab the calculator. Please don't do that. 44 goes into 52 one time. And when you subtract the 44, it's a 44, sorry, from 52, you get 8. And we bring down the other 8. And 44 goes into 88 two times. So W is equal to 12. It's like we're almost done now. Maybe a couple more. All right, looks like we've got a 48 and, oh wait, no, sorry. I can add those together. That's 7n when 8n when I add these together. And then when I add the 8n with the 29n, I get 37n. And it just so happens when I divide by 37 on both sides, I just get 2. Nice, easy one. And not quite done yet. Oh, now we get an easy one. -6 it is. And, oh, now we get one. That's interesting. Okay, so we've got -34n and 47n. When you put those together, it looks like you get 13n plus the 87 is still there. Over here, we're going to have to distribute our -2 to both parts. Kind of a problem. That's 110n. I have a negative times a negative in this first set. And then I multiply -2 times 93, which is going to be 186. It's going to be minus 186. And then I'm going to subtract 94n. 94n. Be careful. I'm going to go ahead and subtract the 94n from the 110n. When you do that, you get 16n. And it looks like we're going to subtract 13n from both sides. And I'm also going to add 186 to both sides. Write it, 186. And that's going to be 273. There we go. And we're going to divide by 3 and get 91. So n is equal to 91. Really seriously, folks, it's a really good idea to practice your arithmetic because it's good for your brain. This is going to be -36r, sorry, I said 36r, equals 36, so r is -1. And we have one last one. Oh, and it's a fun one. All right, so we've got a -95d, and we've got a -59d. And when we put those two together, we get 154, -154d. And then we've got a 62d but we've also got a positive 97D. See that double negative there? That gives you a problem there. So that's going to be 159D, but it's going to be positive this time. And that's equal to 65, it looks like. Well, the nice thing is when you add those together, you just get 5D. And when you divide by 5, hopefully you know you get 13. And we're all done. And that was our last problem. Try doing a lot of the work in your head whenever you can. It's really good practice to practice your arithmetic. It keeps you sharp. So hope to see you back again. And sorry I overtaught a few of those, but hopefully you got them, okay? And I will see you in the next section, hopefully. Bye-bye.